rigid bodies. Okay, so in this lesson we all learned about the center of masses and mass distribution, center of gravity, and what is the relation between the torque and angular momentum and torque and the angular velocity, whatever may be. Okay, everything we learned. What is mean by rotation motion and what is mean by translation motion. What is the relation between the linear momentum and angular momentum and torque and the angular momentum, kinetic energy and the angular momentum, everything we learned. Okay, so what is mean by law of conservation of energy, law of conservation of momentum, and also there is a two what is meant by moment of inertia. When we came with the concept of moment of inertia, there must be a moment of inertia is mass is the measure of inertia of the body, that translation motion. Here the moment of inertia is that inertia, it is called the measure of that rotation motions. Okay, measure of the mass in the rotation motion. Now the moment of inertia, when we are taking over that uniform rod, ring and disc, already we saw everything. Now next also we learned about that what is mean by parallel theorem and what is mean by perpendicular axis theorem. Okay, parallel theorem, when there is a laminar plane parallel will be equal to, then the moment of inertia will be equal to summation of a sum of the axis, okay, which is going in the center, moment of inertia about the center, and then product of mass and the distance between the center and the parallel axis. Okay, so we are taking about the perpendicular axis theorem. One of the perpendicular axis theorem will be equal to the sum of the other two axes. Okay, the moment of inertia about any one of the axis will be equal to sum of the other two axes. Moment of inertia about that other two axes. Okay, all those things we learned. After that we saw the law of conservation of angular momentum. Okay, whenever that I will equal to I omega, so I will be equal to L by omega. Whenever the angular velocity increases, of course certainly the moment of inertia will be decreases. Okay, so when the skate when the snow dancing, when they are doing the snow dancing, and when they are doing the somersault in the air, okay, the swimmers and divers, they are doing this kind of angular momentum. We already saw some of them making the Guinness record also. Okay, now after that we learn about the what is comparison of rotation motion and the translation motion, the relationship between the kinetic energy and the angular momentum. What is meant by kinetic energy? The energy possessed by an object in the which of states of the motion. Okay, so power delivered by the torque. Okay, power equal to tau t theta. All those things we learn. Next one thing, what is meant by the rolling motion? Okay, rolling motion, combination of rolling and translation motion. Okay, what is meant by the rolling motion? The rolling motion is nothing but when an object is rolling. Okay, that is called rolling motion. We know that what is meant by rolling. Okay, so what is meant by translation? What is the combination of translation and rotation motions? Okay, so when you are taking that circle on wheel, okay, whenever the wheels are the whenever the wheels are the motion, what will happen? All the rigid bodies, all the particles, okay, you can take the particles or whatever maybe, everything is under rotation motion except in this direction. When we have the particles are in this direction, they are trying to be in the translation motion. Okay, they are trying to be in the translation motion. Other particles are in the rotation motion. They are making that movement. These two things are making that in the translation motion. This is how they will do in the combination of translation and then rotation motion. Okay, at the center of masses takes only the straight line part. Okay, here they will take the straight line part. All other things will be in the rotation motions. Okay, so the translation velocity VCM will be equal to V trans. All other points are the two velocities. One the translation velocities, the other one is the center of mass, other as the rotation velocity. Okay, this one having that V trans, all those things. Translation motion having that V rotation motions. Okay, so whenever you are taking the point of contact, we have that two things. One is the translation motion, the another one is the rotation motion. Here we will have that combination of translation motion and rotation motion about the center of mass, or momentary rotation motion about the point of contact. Momentary rotation motion of the point of contact. Okay, the motion of seam. Now see, I have the contact point. Here I have only the straight line in the center of mass. In the center of mass, I have the translation motion, which is with the velocity of the center of mass. Motion of the center of mass plus this one plus the motion of the other particles. Okay. Here we have the point of contact. These particles are in the rotation motion. VCM will come in. V rotation. Here we have the V translation, here we have the rotation. Combination of translation and rotation motion gives that the wheels to be in the rolling. Bottom of the wheel has the red, but rest of that at any instant. So combination of pure rotation and then translation will give the pure rolling motion. Pure rolling motion. So V sim will be equal to R omega. V sim will be equal to velocity will be equal to R omega. So this is how the rolling motion will happen in all the vehicles or all the rolling objects. Okay. Now what is meant by slipping and sliding? Okay. Whenever when the round object moves, it always tends to the roll on the any surface, which has to be the coefficient of friction, which is the mu is must be greater than 0. Mu must be greater than 0. Now in pure rolling, there is no relative motion between the point of contact with the surface when the rolling object speeds up or slow down. What is meant by sliding? Okay, we know that. What is meant by sliding? Sliding will happen always when we are stuck with that mud. Okay, sliding, in the case of sliding, VCM is greater than the R omega. That means V translation. Okay, translation motion is greater than the rotation motion. Velocity of the translation motion is greater than the velocity of rotation motion. So sliding will be happen. So the translation motion will be happen. So the wheels are trying to be in the translation motion. Okay, it cannot move inside. That means they cannot provide the sufficient rolling on that wheels. So when we are stuck in the mud, when sliding, it's happening like that. Okay. When the oil is poured on the road, what will happen? It means there is a reduction of friction almost. Okay, there is no relation between the surface of the road and the tire. So that tire should be on that motion, that translation motion. It cannot provide the necessary friction force. So they cannot making the rotation motion. So they are trying to be in the translation motion. So whenever there is a reduction of the rolling motion, that means rotation motion, there will be a not completed by the pure rolling. So that time that sliding will happen. Sliding will happen. That means the translation motion is greater than the rotation motion. When the vehicle enters into the slippery road, in case of the point of contact has more V translation, that means velocity of translation motion, than rotation motion. The resultant velocity in the forward direction. So kinetic friction, what happens to kinetic friction? Kinetic friction will be opposes in the relative motion, hence act in the opposite direction of the relative velocity. The friction forces reduces the translation velocity and increase the rotation velocity. They become equal. The objects test to on the pure rolling are referred to forward slipping. Okay, what is happening to the slipping? Whenever wheels are stuck in the mud, in the case of mud, okay, what will happen? Both will be happening. Both sliding and slipping will be happen when you are stuck in the mud. Okay, when the wheels are stuck in the mud. So when slipping is a good example. Slipping. Whenever what happened to slipping? Okay, here the rotation motion is greater than the translation motion. The rotation motion is greater than the translation motion. That means VCM is lesser than that R omega. VCM is lesser than that R omega. Here what will happen? The kind of motion happens when they suddenly stop the vehicle from the rest or when they stuck in the mud. In case of the point of contact has a more rotation motion. So all the point of contact have a more rotation motion. VCM is lesser than the rotation motion. So they cannot give the sufficient necessary force to move the object from that rest, okay, or from that mud. So that will be slipping will be happen frequently. So in the direction, backward direction, the kinetic friction forces opposes the relative motion. Here the kinetic friction forces opposes the relative motion, hence is act in the opposite direction of the relative velocity. Friction forces reduces and this is the pure rolling motion. Okay, the next one, the kinetic energy in the pure rolling. Kinetic energy in the pure rolling. Kinetic energy in, we know that what is pure rolling? Rolling is the combination of translation and rotation motion. Rolling is the combination of translation and rotation motion. So what will happen? Kinetic energy of pure rolling. The kinetic energy, the total kinetic energy will be equal to kinetic energy of the translation motion plus rotation motion. Kinetic energy in the translation motion and kinetic energy in the rotation motion. So we know that kinetic energy in the translation motion, what is the formula? 1 by 2 mvcm square, because of vcm is the center of masses which is acting on the wave. Okay, here 1 by 2 I omega square, 1 by 2 I cm, a center of masses, moment of inertia about the center of masses. So moment of inertia about the center of masses, we know that moment of inertia about the center of masses we can take it as the mk square. K square is nothing but the radius of gyration. Radius of gyration we can take it as ICM will be equal to mk square. So now we can take it out. There is a relation between the VCM and R omega. Okay, so VCM will be equal to R omega. Now 1 by 2 m R square omega square, capital R square omega square. Okay, plus 1 by 2 m k square omega square. From here take out the common things. Okay, from here take out the common things of m v square VCM square plus half m k square, here omega square. Well, there will be a discussion or there will be a relationship between the radius of gyrations. Okay, mk square omega square. We know that v equal to r omega. From the r equal to v by r. Okay, so we will take out capital. So v square equal to v square by r square. So we will take out v square by r square. V squared by r square. Okay, so take the common things here. 1 by 2 m omega square is nothing but your VCM, right? R square omega square is nothing but your VCM square. So VCM square, here also we have the VCM square. 1 by 2 equal to m r omega, r square omega square we can write VCM square plus 1 by 2 m VCM square k square by r square. Now take out the 1 by 2 VCM square common. Okay, 1 by 2 m VCM square. Okay, plus x square, then it will become 1 plus k square by r square. 1 plus k square by r square. So with the point of reference, okay, this is how the kinetic energy will be acting. With the point of contact or with the point of contact of reference, we know that k equal to point of contact, the moment of inertia will be equal to I naught. So kinetic energy will be equal to half I naught omega square, half I naught omega square in the point of contact. Now substituting that ICM, that point of contact, the center of I naught will be equal to acting in the perpendicular, okay, and the parallel to that one. So what does mean by the parallel? Parallel axis theorem. According to the parallel axis theorem, I equal to ICM plus md square. So here we have the only r square, so r square I naught. Okay, I naught will be the parallel axis theorem, so ICM will be center of masses plus mr square. So substituting that values I equal to, so we know that ICM is nothing but your mk square plus mr square. Okay, mass into radius of gyrations. Now mk square, so substitute that value of I naught, so mk square plus mr square into omega square. Omega square we can take it as VCM by r, VCM by r square. So take the common things here. So first the point of contact, kinetic energy in the point of contact A equal to r I naught omega square. We know that omega square will be equal to VCM square by r square. So I naught will be equal to ICM plus mr square. Now ICM is nothing but mass into radius of gyration plus mr square. So substitute all the values in this equation. So kinetic energy will be equal to 1 by 2 mk square plus mr square plus mr square into omega. Omega square is equal to VCM square by r square. Okay, so whenever you are doing the multiplication, 1 by 2 mk square r we can write m VCM square by VCM square k square by r square plus m VCM square r square by r square. So it will become cancel each other. So it will become 1. 1 by 2. So take out 1 by 2 m VCM square. Then it will become 1 plus k square by r square. 1 plus k square by r square. So whenever you are doing with the center of mass as a reference, you will get half mcm square plus 1 plus r k square by r square. When we having the point of contact, same equations we are getting. So the pure rolling problems has been solved by combination of translation motion and the rotation motion of the center of masses or momentary of the center of masses. Okay, so momentary of the rotation motion about the point of contact, momentary of the rotation motion about the point of contact. Now the next one thing we have to discuss with this one, rolling in the inclined plane. Rolling in the inclined plane. Okay, this is the last one, I think so. Rolling in the inclined plane. Already we know that in the slide what will happen in rolling. Okay, rolling in the inclined plane. Whenever the object is rolling on the inclined plane, what will happen? So there will be a, first we have to draw that free body diagram. Okay, what are the forces will be exerted on that object? What are the forces exerted on that object? So mg cos theta will be acting in this direction. mg sin theta will be acting in this direction. So mg, the normal force, the gravitational force will be acting in the friction forces will be acting on the direction. Okay, friction forces. So this one will be height and this one will be equal to angle theta. Now we know that we have to case with that F equal to ma, Newton's second law. So the what are the forces will be acting here when we are doing the rolling motion? Mg sin theta. Oppositely, the frictional force will be equal to ma. Friction force will be equal to ma. Okay, so we can write this one R, the relation between the friction force. Okay, the relation between the friction force and then torque. Cause the torque that passes through the friction forces F can be said Rf will be equal to the friction forces. R will be equal to I alpha. Tau alpha. Okay. No, moment of inertia will be so I alpha. Friction force will Rf will be equal to I alpha. Moment of inertia. So here the mass. Okay. So now I we can write as A equal to the relation between the angular velocity and the linear acceleration and the angular acceleration. I will be, we can take that as a mk square. Okay, I will be, we can take it as mk square, small mk square. So when we are substituting that one, Rf will be equal to mk square alpha. Alpha equal to A by R. So A square by, okay, so A by R, acceleration by R. Okay, here we have to take that capital R. Now what is that F? F equal to common things. Okay, you can take that F will be equal to mk square A by R square. R I can write ma k square by R square. K square by R square. Okay, so now substituting this one and that equation, m sin theta into F. So m sin theta minus ma k square by R square will be equal to ma. Okay, now we have to take that one ma on the next side. So what will happen? Ma on there. mg sin theta will be equal to ma plus ma k square by R square. ma plus ma k square by R square. When you are taking that mm will be cancelled. When you are taking that a, it's a common thing. Okay, so mg sin theta will be equal to ma will become 1 plus k square by R square. Mm will be cancelled. So g sin theta will be equal to a equal to 1 plus k square by R square. Now we have to take, what is the a equal to acceleration when the motion, when the plane or when the particle rolling on that inclined plane, this much of acceleration it will get. So we know that the speed of the motion, equations of motion, when we have the third equations of motion. What is the third equation of motion? V squared equal to u squared plus 2as. V squared equal to u squared plus 2as. Here we can substitute that value of a here. We can get this one. Okay. Here, what is that? Yes. Yes is the displacement. Here, how much of displacement takes place? Okay. So h. Okay. Height by sin theta. So height by sin theta. Displacement will take by h by sin theta. So we can substitute here. V square. Here u square will be equal to, common things will be equal to 0. So u will be that rest. It will become 0. So v square equal to 2as. 2 into g sin theta by 1 plus k squared by r square. K squared by r square into yes h by sin theta. H by sin theta. When you are doing that things, okay, 2gh sin theta will be cancel each other. So sin theta will become 2gh by 1 plus k squared by r square. 1 plus k squared by r square. So taking the square root, when you are taking the square root, because this is b square, right? When you are taking the b, it will become root 2gh by 1 plus k squared by r square. 1 plus k squared by r square. So we know that v, the first equation, v equal to u plus at. V equal to u plus at. So when you are doing v equal to u plus at, from u equal to 0, so at, acceleration. So t equal to what is that? V by a, right? So v equal to at, then t equal to v by a. And that, okay. We know that what is it? V root of 2gh by 1 plus k squared by r square by a. What is it? A is nothing but g sin theta by 1 plus k squared by r square. G sin theta 1 plus k squared by r square. So when it's taking this one, it will become 1 plus k squared by r square by g sin theta. Okay, we are doing that one. K squared we can take it out. Root of 1 plus k squared plus r square into root of 1 plus k squared by r square. 1 k square, 1 k square will be cancelled. Okay. So here one sin g sin theta. So when you are doing that root of, then it will become sin square theta. Okay. So there will be a 1g and here one will be 1g. So see, I can write this one. Root of 2gh by 1 plus k square by r square into this one. Root of 1 plus k square by r square. By when you are doing this root, it will become g square sin square theta into root of 1 plus k square by r square. So 1 root will be cancelled. When I take this one, 1g will be cancelled. So it will become root of 2h, right? Root of 2h 1 plus k square by r square by g sin square theta. G sin square theta. So this is how the time taken will be taken from the object will roll from that inclined plane. Okay. So radiation of the gyration. Okay guys, from this is how we have finished this lesson. Alhamdulillah. We'll discuss what is important in this lesson. Okay. Thank you guys. Allah Hafiz.